For thousands of years, humanity has looked toward the night sky and asked a single question: are we alone? It's a question that has inspired philosophers, scientists, and dreamers alike. But despite decades of exploration, every mission searching for life beyond Earth has ended with the same answer: not yet, until now. Deep inside an ancient Martian crater, NASA's Perseverance rover has uncovered a rock unlike any previously studied on the Red Planet. At first glance, it seems ordinary. But hidden inside that stone is a collection of clues that has scientists asking an extraordinary question. Could Mars have once been alive? Not civilizations, but tiny organisms that may have existed billions of years before humans. And if that's true, everything changes. Today, Mars is cold, dry, lifeless. Dust storms stretch for hundreds of kilometers, and temperatures regularly plunge below -100 degrees Celsius. It doesn't exactly look welcoming, but rewind the clock 4 billion years, and the story becomes very different. Scientists now believe ancient Mars had flowing rivers, vast lakes, underground water systems, and even a thicker atmosphere capable of supporting liquid water. In many ways, early Mars may have resembled a younger Earth. That's exactly why NASA sent Perseverance to Jezero Crater. Orbital images revealed something remarkable. The crater wasn't always a crater. It was once an enormous lake, fed by rivers carrying minerals and sediments. Everything necessary to create an environment where microbial life could potentially survive. If life ever appeared on Mars, Jezero was one of the best places to search. As Perseverance explored the ancient lake bed, most rocks looked exactly as scientists expected, until one didn't. The rover photographed a section of rock covered with unusual dark spots, surrounded by lighter circular patterns. Geologists immediately recognized something familiar. On Earth, similar textures are sometimes created when microorganisms interact with minerals over long periods of time. That doesn't automatically mean biology. Nature has a habit of producing convincing illusions, so NASA didn't celebrate. They investigated. Perseverance positioned its robotic arm and began scanning. One measured the chemical elements, another searched for organic compounds. Others mapped the minerals in microscopic detail, piece by piece. The puzzle started coming together. The first surprise came from the chemistry. Scientists detected organic molecules, carbon-containing compounds that serve as the building blocks of life. It's important to understand what this means. Organic molecules are not proof of life. They can form through natural geological processes as well, but they are an essential ingredient. Then came something even more interesting. The strange spots contained high concentrations of iron, sulfur, and phosphorus. Together, these elements can participate in chemical reactions that living microbes often use to obtain energy. Even more intriguing, minerals that frequently appear in microbial environments. Individually, none of these prove anything, but together, they begin telling a story. Imagine walking through a forest. You don't see a campfire, but you notice footprints, fresh ashes, pieces of firewood, and food scraps. Each clue alone means very little. Together, they strongly suggest someone was there. The Martian rock presents a similar mystery. Good science doesn't begin by trying to prove an idea. It begins by trying to destroy it. Researchers spent months searching for alternative explanations. Could heat have produced these minerals? Possibly, but the evidence doesn't support temperatures high enough. Could acidic water have altered the rock? Again, the minerals don't match. Could natural chemical reactions explain everything? Some think it's possible. Others argue the probability is extremely low. This is why NASA has avoided dramatic announcements. History has taught scientists to be careful. Extraordinary claims require extraordinary evidence. And right now, that evidence simply isn't complete. Whether these structures were created by microbes or unusual geology, the discovery is remarkable. It represents one of the strongest locations for studying Mars' biological potential. Perseverance has already done almost everything it can from millions of kilometers away. Its instruments are extraordinary, but tiny compared to labs on Earth. That's why NASA's long-term goal is so ambitious. Collect the samples, launch them from the Martian surface, capture them in orbit, and finally, bring them home. Inside those sealed tubes may be the most valuable geological samples ever collected from another planet, because they might answer a question humanity has asked for centuries. Imagine the moment. A small metal tube arrives on Earth after traveling hundreds of millions of kilometers. Scientists carefully open it inside the most advanced labs ever built. Under powerful microscopes, the evidence finally becomes clear. Maybe they'll discover unmistakable signs of ancient Martian life. Maybe they'll prove a natural explanation. Either outcome would reshape our understanding of the universe. Because if life once existed on Mars, then biology may not be a miracle unique to Earth. It may simply be what the universe does whenever the conditions are right. And if that's true, the next discovery may not be whether life exists beyond Earth. It may be discovering just how common it really is. The smallest discoveries lead to the biggest answers. Thank you for exploring the mysteries of Jezero with us.